Welcome to Wildcat Science with Mrs. Haugo. This is Chapter 2, Section 2, Part 7. And today we are going to be using the molar mass of a compound that we learned how to make and using it in different calculations. So first off, we're going to start with converting mass to moles of a compound. And you may be saying, but Mrs. Haugo, we've already done that. And we have done that for an element, and now we're just adding one more step. So you'll be great at this. Okay, first thing you're going to do is you're going to find the molar mass of the compound. And then you're going to set up the problem and calculate just like we did before, where you take the mass in grams over 1 times 1 mole over the molar mass, and that's going to give you your answer in moles. So let's do this. How many moles are in 100 grams of methane, CH4? So the first thing we always do is we write down what we know. So we know we are looking for how many moles, and we know we have 100 grams of methane, and the thing we're looking for is how many moles. Okay, the second step is to calculate, and we're going to first find the molar mass. And if you recall from our last video, to find the molar mass is you find the molar mass of each element and then multiply it by the subscript of that element. So in CH4, we obviously have 1C. It's not written, but if there's no number, it is 1. So 1 mole C over 1 times, and then the molar mass of carbon, 12.01 grams over 1 mole. And then we have, in CH4, we're going to have 4 moles of hydrogen over 1 times 1.01 grams per 1 mole. And then we're going to cancel out our moles. We're left with grams carbon, cancel out our moles, left with grams hydrogen. All right, please do your math and add them up to get your molar mass of methane. If you got 12.01 grams of carbon and 4.04 grams of hydrogen, adding them up to make 16.05 grams of methane, then you are correct. If not, you'll want to double check your math. After we get the molar mass, what we need to do is we need to set up the problem and calculate. So we're going to set up our problem like this. Our original quantity in mass over 1. If you remember, that was 100 grams of methane. 100 grams methane over 1 times 1 mole over our molar mass, which we just found to be 16.05 grams, and that's going to give me my answer. So I'm going to first cancel out the units that I can, and I'm left with moles. And then I'm going to do my math, and I'll give you a moment to do that. Okay, if you got 6.23 grams methane, then you are correct. Good job. Then we're going to check our answer. So we're going to come back up and look at the original problem. How many moles are in 100 grams of methane? Did we answer the problem? No. Did you guys check to see that I canceled out grams? And so my number, my unit, should be moles. If you caught that, good job. So 6.23 moles of methane. So now we'll double check. Did we answer the question? How many moles? Yes, we did. So 100 grams. So let's see, is this reasonable? So if we have 100 grams and we know each mole has a mass of 16, so let's round that up to 20. So 20 goes into 100 5 times, and so it should be bigger than 5. So is our number around 5 and a little bit bigger? And indeed it is. So we answered the question and we got a reasonable answer. Good job. So I would like you to try doing this on your own. How many moles are in 11.9 grams of carbon dioxide? So please set that up and get an answer, and then we will go over that in class. Now we're going to do the opposite. We're going to convert moles to mass. So first thing we're going to do, just like before, find the molar mass of the compound. We're going to set up the problem. And this equation is moles over 1 times molar mass in grams over 1 mole equals my answer in grams. Let's do this. How many grams are in 2.3 moles of butane, C4H10? First thing we always do is we write down what we know. So it says 2.3 moles of butane, and not just to the tens place, we know that measurement to the thousandths place. 2.3 moles butane, which is C4H10, and we're looking for how many grams. Okay, once we write down what we know, we're going to calculate. First up, find the molar mass. So we take the mass, the molar mass of the element times its subscript. So we know in each mole of butane, we're going to have 4 moles of the element carbon. And then so 4 moles of carbon, and the molar mass is 12.01 grams. And then in each mole of butane, we're going to have 10 moles of the element hydrogen. So 10 moles hydrogen over 1 times the molar mass of hydrogen, which is 1.01 grams over 1 mole. So I'd like you to do that calculation and figure out the molar mass of butane. So we have 48.04 grams of carbon and 10.10 grams of hydrogen, and our molar mass of butane is 58.14 grams. If you got that, good job. If not, you'll want to go back and do your calculation. And then the next thing after our molar mass is to set up the problem. So moles over 1, so that was our original quantity, which is 2.300 moles of butane. So 2.300 moles butane over 1 times my molar mass, which I just found out was 58.14 grams over 1 mole is equal to my answer. So please take a minute and calculate your answer. So the first thing you should have done is cancel out your units, and then you're left with grams. So grams come over here, and then you're going to calculate, and you should get 133.7 grams butane. If you got that, good job. And let's talk about sig figs. This one has 1, 2, 3, 4, and we know that these are significant digits because they are after a decimal point. Otherwise, we wouldn't write those zeros. So 1, 2, 3, 4. Right, then we are going to check. We have, did we answer the question? How many grams? We did answer the question. Now let's see if it's reasonable. So if we have 2.3 moles, okay, so that's like 2.5 moles. And so let's round the molar mass into 60. So if the molar mass was 60 and we had 2 of them, that would be 120, and another half, so half of 60 is 30, and 120 plus 30 is 150. So our number, we don't have quite we have 2.3, which means it's between 2 and 2.5 moles. And we said that 2 moles would have a mass of roughly 120 grams and 2.5 moles would have a mass of roughly 150 grams. So is our number between 120 and 150? And indeed it is. So we got a reasonable answer. Good job. So what I would like you to do is we have a practice problem where you may want more practice on this, or maybe you're feeling like you totally got it down. So practice that if you want to. Otherwise, if I might assign that to the whole class, and it is, what is the mass in grams of 2.5 moles of oxygen gas, which is O2? Okay, so in this video we learned how to convert mass to moles in a compound and how to convert moles to mass in a compound. So next up we're going to talk about Avogadro's number again, that beautiful 6.022 times 10 to the 23rd. And when we're figuring out, this will tell us the number of molecules. So please write that down. And when we're dealing with converting moles to the number of molecules, it is the same thing as converting moles to the number of atoms. Because in 1 mole of an element, you have 6.022 times 10 to the 23rd atoms, and in 1 mole of a compound, you have 6.022 times 10 to the 23rd molecules. So please write this down, converting moles to number of molecules. Moles over 1 times 6.022 times 10 to the 23rd molecules over 1 mole is equal to your answer with the unit molecules. And if you, this is the same setup except with a different unit from 2.1. If you would like to do some practice problems as a class or individually, you are more than welcome to do them. I have some available. We could go over them as a class. And then flip-flopping, converting the number of molecules to moles. Well, you're going to start with the number of molecules over 1 times 1 mole over 6.022 times 10 to the 23rd molecules. That's going to give you your answer in moles. So please write that down. And again, if you individually, or I might assign it as a whole class if we need some practice on that type of problem. So let's move on to converting mass to number of molecules. So we're just taking our one-step problems and making them two-step problems. Very similar to what we did in 2.1, but we're adding in the step where you have to figure out the molar mass. So just like in the previous problems, the first step is going to be finding the molar mass of the compound. Then you're going to set up the problem and calculate. So please write this down. The original quantity over 1 times 1 mole over the molar mass of the compound times 6.022 times 10 to the 23rd molecules over 1 mole will give you your answer, and that will be in the number of molecules. So please write down this question. The daily recommended intake of sodium is 1,500 milligrams. This would equate to 3.8 grams of sodium chloride, NaCl. How many molecules of NaCl can I eat in a day? You may be wondering how we got 3.8 grams out of 1,500 milligrams. So you might be saying, Mrs. Haugo, if you convert 3.8 grams into milligrams, it's 3,800. And if you look, sodium chloride is a compound, and sodium is one element in that compound. So chlorine makes up over half of the mass of sodium chloride. So that's why we can have a bigger mass of sodium chloride than the recommended mass of sodium. So the first thing we're always going to do is write down what you know. So please do that. And I have a little bit of a cliffhanger. In our next video, we are going to solve this problem. I will see you then. Bye.